Okay, welcome to Photoshop. This is going to be our first tutorial for the Photoshop unit, and we'll be looking at a number of things. The things you should be paying attention to are terms that I'm using, shortcuts that I'm using, and concepts that I'm talking about. Um, so you should have created a folder, a document folder, like we've done in our past units, just to stay organized. In Photoshop, it's very important that you keep your files organized and know where they are, so that we can access our Photoshop documents, which are our authoring files, and then any of our output files, which are JPEGs and PNGs in some cases. Okay, you will be keeping a number of other files, and that'll be things like source material files that you're going to be using, or kind of original images, or if you're doing like a collage, you may have some elements that you're using. You've learned typography now, you may want to keep some elements of type or elements of type samples that are related to a file. That's the sort of stuff that shows up in other files folder. Okay, so just to start off, before you do anything, get a docket organized. Okay. Okay, so let's take a look at what we're looking at here. We're going to be doing a few things. There are a number of tutorials that we have to work through. Some of these may change, and we may or may not do all of them, but there are some that we do need to do just to get you guys familiar with some of the concepts. And they get more involved as they go, as we get through them. Some of them are fairly quick, some of them are quite long. Like these two are fairly simple. This takes quite a while to get through, and so we'll go through as we have time. We'll go through each of these, and then here are the things you're going to be assessed on. Okay, we'll have a skills test. We'll have a theory test. You have completion tasks to get done. So very similar to what you've seen in Illustrator previously. The skills test, there's a practice, just like in Illustrator, there's a practice skills test, and then we will have two skills tests in the end of the unit, which will cover sort of two parts of the unit, and each of those will be kind of administered on different days. Okay, so that is the unit in a nutshell. There's lots of terms. Photoshop is huge. As a professional designer, I used Photoshop kind of every day for like the entire duration of my career. I was a designer for about 10 years, and I used Photoshop every single day. And I was a professional, obviously. I was getting paid to do it. And I still only knew, honestly, maybe 30% of the software, and it's grown since then. It's just a massive software. There's tons to know. No one can know, I don't think anyone can know all of Photoshop just because it's such a massive software. I mean, maybe there's someone who, but certainly they would be truly professional level. Okay, so that said, let's take a look at what we're doing today. Before we actually get into Photoshop, I need to explain some concepts to you, and that's here. Okay, so we're going to take a look at this unit, this lesson, which talks about a couple of concepts which you've probably heard about, but have maybe not been necessarily explained to you. And these are important for Photoshop, okay? So the main things we're going to be talking about are resolution, okay, image resolution, and some terms that you might kind of hear or at least have heard thrown around are, you've heard pixels, okay, dots, pixels per inch, dots per inch, raster, vector, and screen resolution. Okay, these are terms you've probably heard. You've heard people probably say things like 1080p or 720p or standard or HD. What do these terms mean? What are they referring to? And we'll talk about exactly what those things mean and how they relate to Photoshop. Okay. As we go through this lesson, I'll show you some examples. Okay, we'll look at some images online, and then I'll talk about some sort of important, I guess, terms and important kind of benchmarks, and then we'll get into a lesson at the end of it that you'll have to check another tutorial for. Okay, another video. All right. Okay, so resolution. What are we talking about? You've probably heard people talk about HD. Okay, HD is kind of the standard that we're talking about when we talk about an image these days. And you've also probably heard things like 4K. What's that talking about? Well, essentially you guys are looking at a screen right now, either on your phone or on your, your tablet or on your computer. And each of those is going to show you an image, okay? And in some cases a video, in some cases a static image. Either way, it's giving you information. And that information is displayed in pixels. Okay. Now, pixels are basically small little dots. So what you see here is, I'm kind of going over this part here. Okay. And so if you think of your screen as basically grid paper, okay, like a big kind of like right across the top, okay, all the way across the top and all the way along the bottom, just a big grid paper, except that each of these like grid units is really, really small, okay? And so when we talk about something like 1080p, 1080p, okay, 1080, 1080, what that is talking about is the number of boxes or pixels that would go along the right side or the right edge, kind of top to bottom. Okay, I mean, it doesn't, you could do this on the left edge as well. It just means the number of boxes, 1, 2, 3, 4, all the way down from the top to the bottom of your screen. Okay, so if we're talking about a file or an image or a screen that is 1080p, it means 1080 dots from the top to the bottom. Okay, now in the monitor that I'm looking at, and the screen that you're looking at, the image you're looking at, it's wider than that, right? That width is more than the height, right? If I were using a phone, on the other hand, that phone would be wider. So if I just get a picture of a phone, okay, and obviously a phone is like wider, is taller than it is wide, right? So that's gonna have a different kind of resolution setup, okay? Okay, let's get back to this. So when we're talking about an image, and when we open up an image in Photoshop, the software will ask you what size of image do you want to work with, okay? And it's basically saying how many pixels along the top, how many pixels along the side, okay? We'll be mainly using, for this unit, most likely we'll be using what's called 1080p, which for our purposes will be 1920 across the top and 1080 along the side. Okay, 1920 along the top and 1080 along the side. Okay, that's a typical size. Now, what does that mean? Who cares? What's this got to do with anything? Well, if we think about this graph paper that we're talking about, and the image is made up of all these little dots, right? If I'm looking at a black screen, so I have an image that takes up my whole screen and it's all black. Essentially what that means is if I zoom in really close and look really carefully, I would be looking at a whole bunch of black dots. Okay, if I had a white screen, that would be a whole bunch of white dots like this. That's what you're seeing in these grids. Now what you see here, okay, below this line of text, you can see a single gray line. Okay, right here there's a 1 pixel gray line. That, if you got close enough, looks like this: 1 pixel, 1 pixel, 1 pixel, all the way across, okay, for that many pixels in a row. Okay, and so that's essentially how images are made. Now, this is for a really simple gray line, but if we get into more detailed and curved images, it's the same concept. So what you're seeing here, you'll see actually there are 2 circles, okay, a green circle on a black background. And what the computer tries to do is it tries to smooth those edges, right? And so you've got these black pixels, because a pixel can only be one color. You'll notice that this cannot be more than one color. You can't have a half pixel, okay? So this is black, this is black, this is black. Now disregard this red line. This is just to demonstrate where the circle is, okay? But notice that this is actually one color, that's one color, that's one color. Okay, a pixel can only be one color. It can't be split in half, okay? So if I'm trying to make a rounded image, the computer will try and blend, the colors between black and green to kind of give that smooth, it's called anti-aliasing, between my colors, okay? Now, if we get back to this idea of a graph paper, okay, if I talk about graph paper, you guys know that if I'm using, let's say, a grid that looks like this, okay, I've got 1, 2, 3, 4, 5, 6, 7, 8 by 8, okay, 8 by 8. And I said, okay, making the squares can only be either white or black, and I want you to draw me a circle. Well, it's going to be tough to get any real detail. You might be able to do it, but you kind of would go, make these 4 black, and then that black, and then this black, and then these 4 would be black. So you'd kind of like, it would be very squarish, right? If I, on the other hand, gave you this many squares, you'd be able to do a much better job, a much more detailed circle, because you have more flexibility with your curves, okay? So that's what we're talking about when we get into resolution. So if we look at these two images, okay, you can see that this one is just much smoother. Here we can see kind of where those little jagged edges are. We call this pixelization, okay, or pixelation, okay? And what you're seeing here is just where the computer is limited in how careful or how detailed it can get by the size of these squares, okay? So these are smaller and these are bigger. So obviously, smaller squares is gonna, it's better. It's gonna give you higher definition. It's gonna give you more detail. And the reason that is because it can make these smaller squares can give you kind of more flexibility, more detail. Okay. Now this is what we're talking about when we're talking about resolution. We're talking about how many squares make up, or how many of these pixels make up your image. In this case, it's 5 by 5. So we're looking at a total of 25 pixels making up this square. Here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 by 9, probably. Yeah, 9 by 9, okay? So 81. So there's 81 versus 25. This is a much higher pixel density, is another term you'll hear, or much higher resolution, okay? Now this is still not a lot. If we're talking about an image, if I went and grabbed an image and opened it up in Photoshop, it's going to be significantly more detailed. So I'm just going to open up an image in the background while we're waiting here. Let's grab this for now. Okay, here's a picture of a bird, and this is not even a high resolution. This is actually quite a small image. Okay, but if I zoom in here, okay, what you're going to see is there are the pixels that make this bird image. Okay, and you'll notice that no square can be any more than one color. Okay, now this is actually a very low res image. This is not a high res image at all. This is only, I think, 800 pixels, 800 across. Okay. So that's a really, really small image. In a high resolution, this would be much, much more detail. Okay, so I'm going to close that and come back. Okay, so if we're talking about, for example, here, this is an example here. Okay, we've got, say, 1,000 boxes, okay, across the top and 1,500 along the side. Okay, so kind of a rectangle that's taller than it is wide. Okay, that's 1.5 million boxes. Okay, here we had 81. Here we had 25. Okay, 1.5 million pixels. Okay, so that's going to give you a lot more flexibility. Okay, and so when I say 1080p, that's 1080, and 1920, that's double this. Okay, it's a lot. Okay, sorry, not double. About 150%. Anyway, you get the point. Okay, so a lot. Move on. Okay, so DPI, a measurement of image detail. So what we're talking about when we talk about dots per inch. Now, dots per inch is actually a print term because that has to do with an inkjet printer. But these terms get intermingled sometimes. You'll hear people say DPI and PPI, which is pixels per inch, kind of interchangeably. That doesn't really make a difference in the industry what you say, but just know that those are two different terms. Okay, PPI is pixels per inch, dots per inch is DPI, which is usually for printers. Okay, pixels are the little squares. Okay, and so when I say something has a certain resolution, what I mean is how detailed or how much pixel density I said earlier are we talking about? How detailed is that image? So let's say, and we need to kind of refer to this in kind of real world terms to make it make any sense, because every screen has got a different, not every screen, but lots of different screens have got different pixel density. And so if I say how many pixels are on the screen, if I took this image and looked at it on a phone or my website and looked at it on a phone or looked at it on a screen or looked at it on a smaller, like a laptop, it's going to look smaller. It's going to get squished into the space. And so we need to talk about resolution. We need to use kind of a real world term. And so what gets used is inches. Okay, and what that means is if I have 1 inch of space, how many dots can fit into that space? Okay, and so if I'm talking about, this is more than 1 inch, but let's just say that this square, say this image was 1 inch here by 1 inch there. Okay, and if I was talking about this space, that would mean 72 pixels on one side and 72 pixels along the other. Okay, that would be a 72 dots per inch. Okay, can fit into 1 inch of space. Okay, this is an important number for computers. Now, typically any image that you open up that is on the internet is going to be 72 dpi. This is not such an important number anymore. It was based on kind of limitations of earlier monitors. It's not relevant anymore, but it has stuck as kind of an industry standard. Okay, but essentially, when we talk about anything that's screen resolution, 72 dpi is the number that we're talking about. That means that the image is going to have a minimum of 72 dots per inch. Okay, when we're talking about that's a screen. When we're talking about something that's printed, we need much higher quality. Okay, so if you think about printing an image off the internet, if you took, when you went and got a picture of something and you just went to print it, oftentimes you'll notice the quality is not that good, and you can see those little dots. That's because what we see on a screen and what we see in print are different, because the dots per inch is referencing how many dots of ink are being made on our image. Okay, so if we want to print something that looks good quality, we have to have a minimum of 300 dots per inch in our image. Okay, that means that we have to set this as our benchmark. When we're working in Photoshop, we have got to say, make this image 300 dots per inch. And what it'll do is it'll make it so that every inch has got 300 dots, no matter what you put in it. Okay, now this is a little bit theoretical. You'll start to get a better sense of this once we start working with files, but just remember some terms like, you'll need to remember terms like dots per inch and pixels per inch, and you have to remember this number, 300 dpi being important, 72 dpi being important. These are terms that you'll need to know. You'll also need to know, so this type of image, any image like that bird image, or any image that's made up of dots like this, is called a raster image. Okay, raster, let me find that term here, raster. Okay, compared to something called a vector image. Now we know vector images from this. Anytime an image is made up of math, okay, lines that are affected by math, which we've seen in the past, that's called a vector image, because vector is a math-based term that has to do with mathematical equations, and anytime you zoom in on a vector image, that math just gets recalculated, the lines get redrawn. That's not the way a photo, an image, works on a screen. Okay, this works in Illustrator because Illustrator will just redraw all the math. Okay, but that won't work with a photo. Okay, now I don't have a photo here, but you get the idea. Okay, and so what you'll notice is oftentimes images like this have been made in a vector program, right, and then have been saved as JPEGs. Now JPEG is a raster. If you remember, when we were using Illustrator, we were outputting our files into either PNG or JPEG formats. That's because PNG and JPEG are raster images, whereas an Illustrator file, and a .ai, is a vector image, and a vector image won't display on the internet. It's used for making the file, but it can't display it on a browser. Okay, so even though we know that this when we created this minion, this was vector, this is actually a raster image. It's been, if I could zoom in on this, you would see this gray line is made up of those single pixel dots like we saw over here. Okay? All right, that's about it for raster, vector, and resolution. There's a lot of information on the internet if you need to kind of get that clarified. I found a couple of really kind of simplified tutorials on YouTube, but I just understand what I'm talking about when I say these things. One thing of note, one kind of thing I'll mention, is you may once in a while see 150 as a resolution. That's an important resolution as well. So we had 72, we had 300. 150 is also an important resolution, and that's because that's used for newspaper. Okay, newspapers use a lower resolution when they were printing their magazines, or sorry, printing their images, and that is for two reasons. One, it's expensive to print images, and so by bringing the resolution down, they could save on ink and save on thus cost, and because images in newspapers, they were daily, so that you didn't need to have them for a long time. They weren't meant to last the test of time. They just needed to get the idea across, so they could afford to be a little bit kind of skimpier on the quality of the image. Okay, that's it for now. You're going to move on and check out this tutorial, which I will have on my YouTube account. And you're going to go through this tutorial and create a sphere and then do the extension activity, which is a bowling ball. Okay, that's it for today. Have a great day.